I'm a data engineer at 3 Gimbals. I work on this talk with Dr. Beasley Powson, our VP of Data Science. Fortunately, he wasn't able to make it today, so I'll bring you this talk. So today we'll be talking about mapping information operations with LLMs and knowledge graphs. I'll start by introducing a case study, then I'll talk about some techniques that we used, and then we'll dive into some results of the case study. So here's our hypothesis. We were interested primarily in this because we wanted to use the emerging technologies coming out of the field of machine learning to evaluate media sentiment and bias. And we wanted to apply those evaluations to understand the nuances of Chinese information operations. Now let's jump into some techniques. So I have a feeling that many people here are quite familiar with the field of generative AI. But for those who aren't, I want to give a brief primer on the core principles and tools. At a high level, what we're building is called a RAG pipeline. What is RAG? RAG, or Retrieval-Augmented Generation, is a technique and set of tools used to enhance and ground LLM outputs to be used in reporting or chat interfaces. There are a few components involved in RAG, namely your foundational model, or LLM. That's like Gemini 2.5 or GPT-4o, whatever. There's also your backing storage, that's your vector database, your knowledge graph, your S3 bucket, whatever you want to bring. Your prompts, which customize the outputs in your LLM. Your chunking technique, so that's like if you want to semantically chunk based off of the relationship in the document. It's however you want to slice and dice the data. And then lastly, your retrieval technique. So that's like, that's if you want to score and rank chunks of data to pass to the LLM to see which ones are the best and most relevant pieces of context. So how does this actually all play into GEOINT analysis? Well, we can answer this question by breaking down the stages of our pipeline. With the first stage, called extraction, we mine signals and entities to structure unstructured data and populate a graph. In our second stage, we use the properties of a graph database to link our extracted entities to known entities spatially, as well as co-locate events. And this comes together as our knowledge base. Once we've populated a knowledge base, we actually crawl it at query time and utilize the signals and relationships to retrieve the most relevant content to populate our model's context window, and output your desired values. Sorry, I'm having... Okay, cool. So I want to dive a little deeper into how we actually model our graph structure. So 3 Gimbals values open data formats and open data standards. And so we wanted to represent our entities and relationships using tools from what's called like the semantic web. And so we chose the resource description framework to actually structure our entities and relationships. To actually standardize the definitions and language used inside of the metadata of an RDF triple, we used the Simple Knowledge Organization System, or SKOS. And that's the natural next step, because SKOS builds on top of RDF. And this allows our data model to be extensible and interoperable with other knowledge graphs. Cool. So here's a quick look at some results we haven't covered. So on the right, we have a subgraph representing state-to-state relationships with China at the center. Not only does it look kind of cool, but it also makes complex geopolitical dynamics more intuitive to explore and communicate to both analysts and decision makers. All right, so when we ran this analysis, we began to observe some compelling narrative patterns, particularly in how Chinese-aligned media frame global events. These outlets frequently cast China as a mediator or stabilizing force, projecting an image of calm, order, and constructive diplomacy. In contrast, Western media narratives were more varied and diffuse, lacking a singular, cohesive framing strategy. It's almost like China is trying to offer Europe a big, reassuring hug, a narrative of steadiness in a world perceived as chaotic. One interpretation we explored was that this might be a strategy as a broader attempt to position China as a successor to Pax Americana. One particularly striking example we observed was a contrast in the coverage of similar topics by Xinhua, a Chinese state-backed media group, and Reuters, a Western-aligned media group. The Xinhua article emphasized themes of growth, trade, and partnership, painting an idealistic picture of an optimistic picture of Europe's future, particularly in relation with China. The Reuters piece focused on economic pressure, sanctions, and instability, highlighting the challenges Europe is currently facing. At a first glance, these differences may appear subtle, but when viewed across multiple examples, they illustrate a deliberate use of soft power, shaping perceptions not through confrontation or direct persuasion, but through tone, emphasis, and editorial framing. So this approach lets us analyze China's media strategy, surfacing patterns and topics, especially when coverage suddenly spikes or shifts. We also identify subtle changes in messaging by watching how tone and themes evolve from week to week. We get a clearer sense of emerging narrative and where narrative might be headed. And all this supports a broader goal of generalized influence monitoring. By combining LLMs with knowledge graphs, we can give analysts a scalable and explainable way to monitor the information environment. So if you have any more questions, we can stop by our booth. I can't remember the number, but we're over there. Thank you.